Okay, so today's little video here, we're going to take a look at some of the ways that we use the concept of molarity in chemistry class. So this is based on the previous video stuff, using that idea of molarity, moles per liter. And now we're just going to talk about how that concept gets used. So first things first, moving along. Just as a review, the quick definition of what molarity is defined as moles of solute divided by liters of solution. So keep in mind that when you do these kinds of molarity problems, you always need to make sure that you've got moles of solute, not grams of solute. You might have to do a molar mass conversion first. And the other one is to make sure that you always have liters of solution at the bottom, not milliliters. So move your decimal place over 3 places. One of the first types of things that we have to do, or that we need to do in kind of chemistry applications, sometimes we only really care about one or the other of the ions that might be present. So if we take a salt, we dissolve it in water, it's going to dissociate into its 2 ions. And so we can use the molarity equation in just an extra little step to kind of figure out the concentrations of the ions that are present in solution as opposed to the concentration of the overall compound itself. So let's take a look at what this looks like here. Sorry, that's the same one twice. So, for example, let's say you had a question like this one. What are the concentrations of all the ions present in a 0.75 molar solution of potassium chromate? So that's the kind of question that you could get asked. I want to know how much potassium is present, and then I want to know how much chromate is present. If you're not sure what ions are formed, typically you can just look at the words. The word will show you, the names of the formula will tell you which ions they are. So potassium chromate breaks down to potassium ions and chromate ions. Pretty easy in that sense. So our problem solving strategy. Number 1, you got to figure out what the formula is because you need to know what that is. Number 2, so you have to look up what chromate is. You need to figure out what kind of ions are present in that formula. And number 3, you're just going to multiply. So let's take a look at how this works out. So for example, potassium is K with a 1 plus charge. Chromate, when you go look it up again, is CrO4 with a 2 minus charge. So when we write our overall formula, we get K2CrO4. When this thing dissolves in water, that means we get a ratio of 2 potassium ions and 1 chromate ion every time this thing dissolves. Again, why? Because there's 2 potassium ions that need to be made to form this particular ionic salt. So if we've got a 0.75 molar solution down at the bottom here, that means for every one of those molecules, I'm going to get double that number of potassium ions. So it's 2 times 0.75 moles per liter, 1.5 molar solution of potassium. I'm only going to get 1 chromate ion, so it's 1 times 0.75 moles to get 0.75 molar of chromate ions. So again, it might be more important. I might be more interested in the chromate ions, or I might be more interested in the potassium ions. But again, the only thing you have to do is make sure you write your formula correctly, make sure you know what the ratio of ions is, and then you multiply. Multiply the solution concentration by the number of ions that are present. Not too big a deal. Okay, next step. This is actually probably more important, is how to prepare different kinds of solutions. So a lot of times, like if I'm setting up a lab, it'll say, I need 125 milliliters of such and such strength solution, and how do I go make that particular thing? So I've got an example on here. You need to make 125 milliliters of a 0.2 molar solution of nickel 2 nitrate. How are you going to do that? Well, this is based on the molarity equation again, moles per liter. So what do we need to do? Number 1, make sure that you know what the equation is. But then what we're going to do is we're going to take our formula right here, we're going to rearrange and solve for moles of solute, because I need to know how much nickel nitrate I need. And that's going to come out of that moles of solute. Eventually I'll get moles, I'll have to convert it to grams. So next thing I'm going to need to do at some point in time, make sure I get that chemical formula. If I have the formula of nickel 2 nitrate wrong, I can't get the molar mass right. So can't do the next step, right? Calculate molar mass. And then the last thing, once I know how many moles they are, I'm going to convert moles to grams. So again, solving first using the molarity equation, solve for moles of solute, and then you're going through those steps to convert those moles of solute to grams. So here's how it's worked out. All right, here we go. We have a 0.2 molar solution. This was given to us in the problem. Here it is, right? 0.2 molar solution. We're given 125 milliliters. 125 milliliters is 0.125 liters. Remember, you have to move that decimal place over 3 times. And so we solve, and we end up with 0.025 moles of solute. Again, it's just simple algebra to rearrange for this. We know that nickel 2 nitrate has to have the formula of this, NiNO3 2, because nickel means it's a 2 plus charge. Nitrate is a 1 minus charge. That's where this outside 2 comes from. And then I go through the molar mass step. There's 1 nickel, there's 2 nitrogens, there's a total of 6 oxygens, so it's 182.7 grams per mole for that when I do the nickel nitrate molar mass. Last step is to do that final conversion. I had 0.025 moles of nickel nitrate. it's 182.7 grams per mole, so I would have a total of that many grams, or I would need that many grams. So to write this all out as a correct equation, it's a little bit longer answer than maybe you'd want to write. Number one, 3 sig figs, so it's 4.57 grams. But the way you would write this out, you'd say I'd need to add 4.57 grams of nickel nitrate to enough water to make a total of 125 milliliters of solution. So literally the way you do that, you take, get about 100 milliliters of water, put your nickel nitrate in there, dissolve it, and then bring that final volume up to 125, just a little bit of a picky thing. So there you go. In applications, 2 quick applications of the molarity equation. Number one is, Number one is making sure that you are dealing with moles and not grams, so make sure that you're using molar mass. It's kind of important. Number 2, make sure that you're using liters and not milliliters. Move that decimal place over or divide by 1,000, however you like to do that. Algebra, I see people do this algebra, by the way, all the time wrong, so be really careful. If you have to solve for volume, that equation gets mixed up all the time, so please be really careful with that. And our 2 applications that we had in this last video. Number 1, ions in solution. It's just simply a multiplication factor against that concentration. And then solution prep. Solution prep is going to ask you indirectly for a quantity in grams. So you're solving for moles of solute and then converting for grams. So there you go. Last couple things, if you're looking for a 4, there's some other ways that we can calculate solution concentrations called normality and molality. They're closely related. They're not quite as common, but you can look up those and tell me under what kind of circumstances those 2 kinds of things might be used. So there you go, your basic ideas about molarity, calculating solution concentrations, ion concentrations, and solution preparation. See you in class tomorrow.